In 1869, the explorer John Wesley Powell was rowing his boat through the Rocky Mountains when he found himself on a river that had absolutely no business being where it was. He'd been following the Green River from Wyoming, where it started off like a normal mountain river should, just collecting meltwater and winding its way south through flat plains. But then, soon after it entered Utah, it took a sharp turn straight into a gigantic mountain range, the Uintas. Geologists spent a century and a half questioning why a river would suddenly cut into a towering mountain instead of just going around it. And they came up with plenty of wrong answers. But in a study published in 2026, one group found an explanation that seems to hold up. Not only does it finally solve this century-and-a-half-old mystery, it shows how invisible shifts deep under our feet can completely transform the surface landscape and the lives of everything on it. Here's the thing. We know a river can carve up a landscape, and it's not like the Green River is some kind of weakling. Back in the day, Powell wrote that the water got so strong it threw them around like bucking ponies. Plus, it sank tons of wagons in the original Oregon Trail game. This river does not mess around. But water, as a general rule, is lazy. It's not going to bore through a mountain unless that's the easiest way for it to get where it's going, which it's usually not. So after Powell rode through the enormous gorge at the entrance to the Uintas, he pondered how this could have actually been the Green River's path of least resistance. Maybe, he hypothesized, the Green River was really old, and at some point, before these mountains even existed, it was just meandering across flat land. Then one day, the land started rising up beneath it. Maybe it rose so slowly the river could erode what was beneath it faster than the land rose. That meant the river could keep its original channel and just slice through the mountain without expending any extra energy. Because as far as the river was concerned, its path stayed flat all along. Powell called this an antecedent river, and today we know this is a thing that happens. For example, across the Himalayas, powerful rivers like the Indus seem to have cut into the land fast enough to survive the rising of the mountains. But this is not what happens to the Green River. Even before geologists had the technology to figure out the exact ages of rocks, they found clues that the Uinta Mountains were around well before the Green River. One big clue was a bunch of debris that had come from mountain peaks on one side of the river canyon, but was found on the other side. If the river had already existed, any debris that came rolling along should have just plopped into the canyon and stopped there. The fact that it made it all the way across suggests there was no giant canyon at the time. But how much younger was this river? Well, for reference, geologists know the mountains were there at least 50 million years ago. That's based off the age of sediment layers in some local basins, which had been filled as debris washed off the rising mountains. As for the river's age, we have to head over to an area called the Browns Park Formation, which the Green River currently cuts through. Millions of years ago, wind and water filled up this low-lying area with stones and gravel. However, it doesn't look like this stuff was dumped there by a major river. Some deposits form layers of ripples as they fell out of standing water. Other deposits are spaced out in broad fans, the kind of pattern geologists expect from networks of small streams and lakes. So it seems that the Green River still wasn't around when the Browns Park Formation emerged, a process that ended around 8 million years ago. That's more than 40 million years too late for Powell's antecedent river idea to work. So the question remains, how did a geologic baby of a river end up slicing through these far older mountains? One hypothesis suggested the Green River formed on a layer of soft sediment that once completely buried the Uinta Mountains. By the time the sediment had eroded away, the river had gotten so big and so powerful, it could slice into the mountains like a saw blade, sinking into them as the sediment wore down. This is a phenomenon called superposition, and once again, it is a real thing, but that alone couldn't explain what happened in the eastern Uintas. Sediment had never piled up high enough to make this a real possibility. So other geologists tried to explain the strange path of the Green River through river capture. In the 1930s, some hypothesized that a small but mighty stream on the south side of the mountains had started eroding northward until it backed into the Green River, which at the time flowed east, not south. Once that connection was made, water from the Green River suddenly poured into this new pre-made channel with enough force to transform it into a deep, wide canyon. That idea idea still didn't answer how a small but mighty stream could have been powerful enough to bore through the mountain in the first place, but at least it was on the right track. In the 1960s, after about a century of wrong answers, geologists started paying more attention to the idea that the Green River once flowed toward the east. They found layers of ancient rock that had been deposited northeast of the Uintas, opposite where the Green River flows now. They also found specific types of gravel from Wyoming mountains so far away they had to have been carried by a major river. So the Green River must have flowed that way at some point, until something captured all its water and sent it flowing south through the Uintas instead. Then geologists realized the land had shifted sometime after the mountains formed. Based on the tilt of the rock layers, they estimated that the mountains had sunk around a kilometer and a half into the earth 20 or so million years ago. The land around them tilted downward, kind of like a cushion with a heavy ball sitting on it. With this metaphorical gate lowered, streams south of the mountains could lazily flow and erode their way northward. Meanwhile, the land to the east was rising. It got so tall, in fact, that a bunch of rivers and streams that had been flowing northeast started going the opposite way. Remember, water is lazy. Put one and one together, and eventually the Green River and all its tributaries got captured by a stream coming up from the Uintas. Fast forward some millions of years, and you've got an explorer and his crew boating down your weird river. It seemed like the pieces were finally coming together, but there was still one problem. If all this really happened, what was responsible for stirring up the land in the first place? Remember, the Uinta Mountains formed around 50 million years ago, and they had stopped growing. The region was supposed to be dead, geologically speaking. It wasn't until this 2026 paper that one research team finally put it together. They focused on one particular clue. All around the Uinta Mountains, rivers abruptly change character at a certain point. They start out wide and gentle at higher elevation, and then downstream they suddenly turn steep and more aggressive. That transition point tells us something geologic happened, and the details suggest that something was an uplift. See, something funny happens when a mountain rises up under a river. The mountain rises like a dome, so the land at its base tilts upward the most. The water starts flowing faster there, speeding up erosion and creating steep and narrow river channels. Over time, the location of that changeover starts creeping backward, aka up the mountain. We just happen to be in the middle of that creep, hence the kink in the middle of all these river channels. And since rivers are so sensitive to the slope of the land, the research team could analyze the older parts of the river channels, the stuff near the top of the mountains, to reconstruct what the whole region looked like before the uplift. This technique is called 2D topographic inversion. Basically, it analyzes the width and depth of river channels, and it uses a formula to calculate the elevation where they originally formed. Long after the mountains were dead, they had risen over 400 meters. However, that uplift wasn't uniform. The center of the range had risen the most, and the rest of the uplifted area made a bullseye pattern around it. It was that pattern that blew this whole case wide open. Geologists could finally identify a probable cause for all of this, a phenomenon called a lithospheric drip. The idea is this: mountains are kind of like icebergs. A big part of their mass sits below the surface, and under a heavy mountain, heat and pressure can make the mass at the bottom extremely dense. Eventually, it gets so dense down there, the rock becomes heavier than the layer of earth underneath it and starts to sink. At first, it pulls the whole surface of the earth down with it, which, let's take a moment to appreciate how wild that is. And then finally, it breaks off and drips toward the planet's core. When that break happens, the crust above it rebounds, and this kind of uplift creates a bullseye pattern, just like what we see in the Uintas. To test their hunch, the team behind this 2026 paper studied existing images of Earth's interior, hunting for the fallen drip. The images were created using a technique called seismic tomography. It works kind of like an X-ray, letting scientists map what's under the surface based on how quickly seismic waves travel through it. Sure enough, they found a weird, dense blob sitting about 200 kilometers below the surface. It was between 50 and 100 kilometers wide, and they estimated it broke off from the crust between 2 and 5 million years ago. So it seems like the scientists finally have their answer. A few million years ago, the Green River was flowing east, but as the land to the east rose, the river started to stagnate because it couldn't flow uphill. Meanwhile, a big old chunk of super dense rock stuck to the bottom of the Uinta Mountains was busy dragging everything above it down toward the Earth's center. And with a lower barrier to entry, literally, the Green River could find a new exit route straight across the mountains. Over time, its waters carved a new channel over the sunken mountain peaks. It flowed all the way south till it met the Colorado River and merged with it. Then one day, millions of years later, the underground drip finally peeled off from the rock above it. The Uinta Mountains began to rise again. The geologic barrier was put back up, but the Green River was already there, trapped in the path it had carved. As the land rose, the water kept carving into it, creating the giant canyon that befuddled Powell's crew in the 19th century and geologists for the next 150-odd years. But befuddling scientists isn't the only feat this dense blob of underground rock accomplished. By lowering the Uintas and allowing the Green River to cut across them, allowing it to connect with the Colorado, that blob indirectly cut up the landscape and created the stunning canyons that Utah is famous for today. But also, it drastically changed how water moves across the continent. Water that used to eventually drain into the Gulf of Mexico now traveled west, winding up in the Pacific Ocean instead. And of course, the merging of two major rivers means you suddenly have a bunch of aquatic species interacting with one another that never had before. What a day for evolution, not to mention the millions of years that followed. And to think, this all started with a guy noticing the river he was boating down wasn't lazy enough. Science is kind of awesome.